Yeah, I am ready to discuss something. I selected a quadratic equation. In details, it will be covered with you. I hope all of you are ready. Quadratic equation. I am talking about this quadratic equation. Uh, do you know that it is a mathematic tool for physics? Quadratic equation is necessary for physics. You will be understanding this for physics as well for mathematics. I don't know what is your purpose to watch this lecture. I'm telling you that if you are watching this lecture for mathematics, then it is for you. A student who are watching this for mathematics, for physics, yeah, they are correct. They can watch. Okay, I want to start this quadratic equation. Look at over here this word. It is clear telling you, this is clear telling you quadratic, which means always remember quadrant. I am not saying quadrant, it is a quadratic, which means two two. But here this is a 2 is a number, but it is an exponent. Okay, 2 is the exponent of a variable. If a variable is containing two exponent, two exponent, then that polynomial would be what? Quadratic. So meaning of simple meaning of a quadratic equation is just two exponent. Highest exponent is how much? 2. And equation meaning of this equation is just equal sign. In LHS side will be something else, will be something. In RHS will be something. In both sides there will be quantity. One side will be equal to another side. This is what is the meaning of equation. Okay, this is what is the meaning of equation. A polynomial which is with a equal sign. Now look at over here. An equation of the form. This is a general form of a quadratic equation. You will see use of this general form in your equation. Sometimes question would be saying that yes, I am giving you polynomial and just decorate it in your general quadratic form. Then you will understand, yes, general quadratic form is this. Then you will decorate your polynomial into this form. Your question will come to you, don't worry. Right now we are understanding by looking at over here that ABC, all these are real numbers. Okay, ABC, all these are real numbers. But I am not saying X is also real number. No, X is a variable. ABC are real. Yeah, I am breaking down it each part. Can you tell me in this quadratic equation, I can confidently say that yes, this is a quadratic equation. This is a quadratic equation. Why? There is a reason. I will tell you that reason. Look at over here. What are numbers of terms in this quadratic equation? You would say this one, this second, two, this third, and this fourth. There are 4 terms. Yeah, you are correct. All people are correct. There are 4 terms. You will realize now you will realize that name of each terms, name of some terms will be something else. For example, name of this A will be what? Coefficient number. Name of this X will be variable. Name of this will be coefficient number. X again variable. C is a constant number. So here you are observing name of terms, and this 0 is also constant. Look at over here. So remember, any number, what would be definition of a coefficient number? What should be definition of a coefficient number according to you? Okay, if you now then, okay, very nice. Also, I want to explain definition of coefficient number. Coefficient number is a number, okay, constant number you can say, but it will be with variable. This is the main point to define coefficient number. A number which is with variable is a coefficient number. A number which is not with variable will be constant number. Clear? Constant number is also known as a fixed number. Remember. Okay. You understood? Coefficient, constant, yeah, variable. Why do we use a variable? We use variable because we don't know value of something. To unknown things we use a variable. Look, this plus, minus, multiplication, division, all this will come in your quadratic equation, in your polynomial. So remember, all this hints is nothing but just a operator. Okay, you can say also, yes, there is operator, but what operator? Plus or minus or addition or multiplication? You will have to clarify. Okay, so here you are saying plus, minus, multiplication, division, all these are operators of mathematics. Okay, in this quadratic equation you can see highest exponent is a 2. Highest exponent is a 2, which explains definition of a quadratic. Okay. In a polynomial, if highest exponent is a 2, will be quadratic. If highest exponent is a 3, will be known as a cubic. If highest exponent is 1, then that variable will be linear equation. Based on degree, we are classifying. Okay. Based on term, polynomial can be classified, but we will understand that later. If there is a one term, what will be name of that term? If there are two terms, what will be name of that term? Clear? Okay. Look at her. Focus over here. I said ABC would be real, but remember, only A should not be equal to 0. This is the condition. We cannot exploit this rules. Yeah, you can put 0. You can put 0 in place of B, in place of a C, but not in place of a. This is what is the rule of a quadratic equation. If you put, what will happen when we will put 0 in the place of A? Then what will happen? Just it will become something else, or you can say it will become linear equation, not a quadratic equation. When 0 will be put in the place of a x, then it will this whole will become linear equation. Clear? but here we need quadratic equation. Okay, till here we are something clear. ABC are constant and x is a variable is equal to quadratic equation. Number of solutions is equal to maximum power of x. So maximum power of x is how much? 2. So it is telling you number of a solution would be 2. If a maximum power of x variable is 2, then you will see roots are coming to time. Output of one input, you will realize that there are two outputs of one input. This will happen because of highest exponent of the polynomial is 2. That's why if highest exponent of the polynomial is 3, then your answer of the polynomial will be 3. Okay. Okay, we will see with the equation, don't worry. Solutions of the equation are values of x which when we put in LHS, then LHS will become 0. Yeah, here you can see whatever will be value of x, when we will put value of x in this quadratic equation, then you will observe that this LHS is becoming 0, which is equal to RHS. This is what you will observe, and it's a truth. It should happen. I would say it should happen. That's why we are understanding mathematics, isn't it? If in this side is 1 by 2, then you will observe that LHS is also coming 1 by 2. Okay, both will become equal, and here we are applying equal sign between two quantities. So here we have two solutions. Okay, let's see with question. I said you that I will tell you with question. This x1, it is x1, and this is another x2. So here we have inputs. How much? 2 inputs. Not we have one input, and output of one input is a 2. This is what we are observing. So it's a 1, and this is another solution answer. Just you can see what's the difference between this and this. Just operators. Here this is a plus, and here this is a minus. In one x there is a plus, and in another x there is a minus. This is just a difference between them. Next, it can be equal to this minus b upon a, where b is a coefficient number, a is also coefficient number. X into x1 into x2, this is equal to c upon a, where c is a constant and a is a coefficient number. For example, for instance, in equation, this is an example. 2x square plus 3x minus 6 is equal to 0. Okay, here we know that a is nothing but 2, b is 3, and c is minus 6. We have a formula which is this x1. So minus b plus then under root b square minus 4ac, then upon 2a, I think 2a, yes. You will substitute value of a variable. Value of this is this much, this much, this much. Just substitute, and then at the end you will get this much. x2, in this just this will become plus, minus. In this what is happening? It is coming. Next we have x1 plus x2. We are adding this and this. After adding this and this, so you are saying that sum of two zeros. You are saying that sum of two zeros is how much? Minus 3 upon 2. This is what we are saying over here. This is 1 0, this is another 0, and sum of these two zeros are coming minus 3 upon 2, and product of these two zeros are coming how much? Minus 3. When you will multiply this by this, then minus 3 will become as output. Next we have if b square minus ac is a greater than 0, then what will happen? Remember, discriminant will tell you nature of roots, I think, yeah, nature of a solution of a quadratic equation. Who will tell you? Discriminant. So it is telling you if d is greater than 0, then what will happen? It will be equal, not equal. It will be unequal and real. It will be unequal and real number. Okay. Whatever will be coming, the value of x will be real but unequal. Means value of one variable will be different from the other variable, from the other x variable. Two real and distinct solutions or rules. If t is less than 0, in that case imaginary number will come and both will be different. If b square minus 4ac is equal to 0, d is coming as a 0, in that case real that root will be real. Okay, that root will be real. But you will observe that those roots are equal. If one root is a 1 upon 2, then another root will be also 1 upon 2. And it is happening because of d is equal to 0. That's all. Now next we have this minus 4. I. What is happening over here? 4 multiple minus 1. 2 to the 4, 2, and here we know that minus 1 is equal to I square. Value of I square is minus 1. Here you can see this is a value. 4 is not 4 only, minus 4 is a value of a discriminant, and it is a less than 0. That's why we will get imaginary roots. That will be 2. Minus 1, and minus 1 is just I square. Next, x square plus 2x minus 8 is equal to 0. This is the expression. Okay. Same equation can be represented as this: x square plus 2x minus 10 is equal to minus 2. X square plus 2x is equal to 8. Both are same. Nothing is a change. Both are same. When you will simplify this, then you will get this much. This is what is happening. Clear? After simplifying this, one step ahead, then in the next step you will be getting this much. Clear? When expression is equated with something, it becomes equation. For example, x square plus 2x minus 8 is equal to 0. It is the equation because of here we added this equal sign. That's all. If we will remove this equal, then it will not become equation. Expression equated with 0. Yes. Here this is equated with 8. Expression equated with 8. y is equal to x square, equation of a parabola. This x square is known as a parabola. Remember, y is equated with x square. When y is equal to 4, when y is equal to 4, when we will put this 4 over here, then what will become? It is giving you x as a 2, x as a 2 or x as a minus 2. Here you can see this minus 2, it is giving you minus 2 or plus 2. This is what is happening. And the next, if we put y as a 9 in this equation, then what will happen? X will come as a 3 and minus 3 and minus 3. Let's draw this equation on a graph to visualize. Here you can see this is y is equal to 4. So y is over here. This is y. Okay. If we put here y 4, then x is coming how much? 2, then plus 2. This plus 2 and this minus 2. So it will go like that. It will go like that. Clear? Now next, y is 9. So y is over here. This is 9. And x is coming how much? Plus 3. Plus 3 minus 3. So remember, this is a 3. This is a 3. It is a x as a minus 3 and this is a x as a plus 3. Arranging shifting. Look at this graph. What is happening over here? This curve was over here, but when it is shifted over here, then what is happening? It is now this is over here. What is happening over here? This would be our y and this would be our x. This is our x and this is our same here would be x. But what about this? Y is equal to x square minus y is equal to 0. Yes, okay. Now the graph is pulled towards the right by units. Initially, y was 0 at x is equal to 0. Now y is 0 at x is equal to 2. Everywhere x will be replaced by x minus 2. New equation, y is equal to x minus 2 raised to power 2. In initial equation, this was and then new equation, this became x minus 2 raised to power 2. Similarly, if a curve is shifted by a unit in left direction, the new equation of parabola is y, this x plus a. What is happening over here? If curve is shifted in this direction, and with how much unit? For example, y is 0, but x is a integer, but not a 0. Okay, in that case, if this curve is coming in this side, then here we will apply just minus. If a curve is going in this side, then we will apply positive. Whatever is a unit that was shifted this with unit, we will write with this. Okay, y is equal to x square. Parabola is shifted downwards towards a negative by 2 units downwards. Here it is talking about this downward by 2 units. Y is equal to x square. Replace y with y plus 2. Y plus 2. Here just opposite. If we are going in negative, then add plus. If we are going in positive, then add minus. Y plus 2. With the 2 units we are decreasing. We are decreasing it with the 2 units. So y plus 2 is equal to x square. Y x square and here y is equal to minus 2, then it will become this is a 2, this is also 2. X square minus 2. For example, y is equal to x square is equal to 0, and x will be equal to 0. Y is equal to x square minus 2. Then if we put 0 in place of y, then it is coming this much, and it is giving you this much. X is equal to root 2, then x2 is equal to minus root of 2. Minus root of 2. It means this is going in this direction. Minus root of 2, not root of minus 2. Minus root of 2. You know that value of root 2 would be just 1.4. I think so, 1.4. Similarly, if a parabola y is equal to x square is pulled in upward direction, then y plus y by b units, the new equation of a parabola just y minus b. Here we are pulling the curve upward. That's why, and this curve is going in positive. Just we will apply opposite operator of a positive. question right now we have y is equal to x square is pulled by 2 units towards a plus x direction and 1 unit yeah, continue. uh, we have this question is asking if y is equal to x square is pulled by two units towards positive x direction and 1 unit toward minus y direction in this direction and in this direction. So this is 2 units over here from here and in this 1 unit. Okay, find a new equation of a parabola. 2 unit in this direction and 1 unit in this direction. How will graph look, curve look? Y is equal to x square and here y is equal to x minus 2. Yeah, x minus 2 raised to power 2. And this is going in negative, so it will become y plus 1 is equal to this much. When we will simplify this, it will give us something. You can see y plus 1 is equal to this much. After simplifying this, it is giving us quadratic equation. Y is equal to x square minus 4x plus 3. Then parabola is becoming y is equal to x square minus 4x plus 3. What is happening over here? Question was saying if curve is pulled in minus y direction just by 1 unit, so it is going in negative y. So that's why can we say that y plus 1. What is the meaning of this? Y plus 1, meaning of this is that a curve is going in a negative y by 1 unit, okay. And it is also going in positive x direction by just 2 unit, clear? So if this is going in positive, so of course we can say x minus 2, and here a square is coming. I think a square is coming just for this 2 representation. Here we can see y plus 1 is equal to x minus 2 raised to power 2. Then after simplifying, it is giving us something. Checking for y is equal to 0. If we put a value of y as 0, then what will happen? What will x come as output? So x square minus 4x plus 3 is equal to 0. It is becoming quadratic equation. Now this became quadratic equation. X square minus x minus 3x plus 3 is equal to 0. After simplifying it, it is giving you 2 roots. X has a 1 and another x has a 3. So what is happening over here? This y is equal to x minus raised to power 2. This is a 2 and this is a, it is a 2, not a 2. I think this is a 2, this is 2, this is 1, and this is a 2. So x here over here, x is equal to 3. Exact graph is over here. X is equal to 3 over here, this is, and another is x is equal to 2, this is over here, x is equal to 1, and this is y is equal to -1. So rather than this come over here, it is coming over here, and here x is a minus, x is a +1, and this is x is a +3, and y is over here. This is the intersection. We are not caring about x as a 2. So this is a graph, this is a curve of this, y is equal to x square minus 4x plus 3. Next graph, y is equal to x square, okay. This is graph. Now if above curve is pulled upwards, now if above curve is pulled upwards by 4 units, and towards right this side in positive x direction by 3 units, draw the new graph. Hold on, if it is going upward, suppose y minus 4 and x minus 3 raised to power 2, this is what is happening. So here x minus 3 raised to power and then y minus 4, because both are going in positive axis, isn't it? That's why. So yes, I am correct. Y minus 4 is equal to, but hold on brother, this is also minus, because one equation was given you already, which is y is equal to minus x raised to power 2, this equation. And this is over here, minus x square. Okay. If it is shifted by the equation, then this will come over here, of course, where y is equal to 4. Now look at why did we take y minus how much, 4y? There is a reason, and reason is that when we will equate this with 0, then it is giving us 4, and here we can confidently say that yes, y 4 is a add to positive y over here. This is the reason behind taking this negative operator. If you take x minus 3, then what will happen? x minus 3 is equal to 0, and it is giving you x as a positive 4. Are you understanding? But a square, why a square is coming? I think a square is coming just for this. A square is coming because of we are in the context of a quadratic equation. That's why. Okay, no problem. So y is equal to 4 over here, x is equal to 3 over here. X square, x1 is coming this, and x2 is coming this much. So curve will be like that, and this is a coordinate y 3 comma 4. What if I say, let's create one question by ourselves? A curve which is going in negative x-axis, just pi minus 5. What I am saying x is equal to minus 5. This is what I am saying. It means yes, this, and it is going upward or downward. Curve is going downward. Okay, by 3 units, by 4 units. So of course minus 3, it will be minus 3 because of this is a downward, it is going downward, that's why. Okay. Now 1 is giving us how much? Hold on, yeah. It is giving you x plus 5 is equal to 0. This is what is coming over here. And second is y plus 3. So we can easily say y plus 3 in bracket is equal to x plus 5 raised to power a square. Okay, x plus 5 raised to power a square. We will simplify this, then something will come, then we will put the value of y as a 0 so that we can represent our quadratic equation. Okay, our quadratic equation. After simplify this, we will get something. Value of roots, 2 roots we will get. Then we will be able to draw a curve according to this equation on graph. Y minus 4 is equal to minus, okay, x is equal to 1, and then another is 5. So here we can see this 1 and this 5. Roots of a quadratic equation represent intersection of a parabola with the x-axis. Yeah, we saw intersection here. So finally we have completed a quadratic equation. Now let's explore something else. Binomial theorem. Binomial theorem. Arithmetic progression, let's explore. Yeah, arithmetic progression series. We are familiar with the arithmetic progression. We have learned this in I think in 10th standard. you can consider it as a revision. A arithmetic progression is it is written in just a short form, which is AP. A stands for arithmetic and P stands for progression. Progression, which means progress. There is a progress. Arithmetic. We will see meaning of arithmetic. Don't worry. Series. What are you understanding by series? There is a series. One, then again one, then again one, then again one. It is increasing. It can be decreasing. But there is a series of something. It can be a series of natural number, a series of integer number, anything, a series of object, anything. Okay, a series of the form of this. Hold on. Here first term we have a, then comma a plus d, then comma a plus 2d, then comma a plus 3d, a plus 4d. Like that it is increasing. You can easily observe that yes, this is increasing by just a number. Okay, this first term is just a, and in another next term, in a second term, it is added by a number. Then in third term it is added by d number, but by 2 multiplication. Okay, this is what is happening. It is added, this third term is being added by 2d. Yeah, this is what is happening over here. So this is a series of a something we don't know. Here we can say this is a series of number, and this is where we say that yes, this series will be known as arithmetic progression. This is where. Okay, this a plus n minus 1 into d, this is used for a noun term. Remember, this will be used for a noun term. In details we are going to explore, don't worry. Right now you understood meaning of arithmetic progression. If you didn't understand, don't worry, we are just starting right now. Okay, now where d is equal to second term, how to calculate d? Okay, how to calculate, and d is nothing but just d stands for difference. Here we are not adding, rather than adding we are subtracting second term by first term. This is what is happening over here. So d, meaning of d, not meaning, d is just a difference. Difference. You will see importance of a d. You will realize on that. So question is coming, how to calculate a d? Just subtract first term from second term. So a small thing will be subtracted from big thing. Okay, this is what will happen. Of course here you can see, so this minus this will become d, this minus this will become d, this minus this will become d. Is known as a common difference. Here you can see this is a common difference. When you will subtract like that, this minus this, this minus this, then value of this will be same. Value of this is coming something, for example 5, then over here it will be also 5. In the next will come also 5. For example 3, 5, 7, 9, 11. It is a continuum. There is no end. Okay, there is no end. We can easily say that yes, this is a series of number. This is a series of number. One thing more you can say, Yeah, this is a odd number. This is series of odd number. By observation, by observing, we are saying that yes, this is a series of odd number, odd natural number. More clarification. We are giving more clarification. Okay. So first term would be what? Just 3, second, 5, third, 7. Like that you will identify. What if a question asked to you, what is that number which is at 25 place? Then what will you do? Just there are 5 numbers which is given to you, and question is asking what is that number which is at 25 place. And to calculate this number, we will have to use a formula of arithmetic progression. This is not complex. After understanding it, you will enjoy this formula of arithmetic progression. Not just calculating this number, also there are more uses of this AP. You will see. So first term, this 3 is the first term, and second term is 5, third 7, and fourth is 9, and next is 11. This we can say that yes, 11 is at 5th position, 9 is at 4th position. That is how we say. Okay. So A, we will consider this first place as A. So A is equal to 3, and then first number we will consider it as A. A is equal to 3. The next second term, here we are saying A plus D. So this is telling that A plus D is equal to 5. You can see what will be D? Just 5 minus 3, you will get a 2. 7 minus 5, you are getting 2 again. 9 minus 2 minus 7, again you are getting 2. That's why we were saying yes, D is equal to bigger term minus a small term is equal to is nothing but a common difference. And here you can see common number. 2 is coming again and again. That's why it is named as common difference. Okay, common difference. Okay. So D will be what? 2. Now A is how much? 3. D is 2, and this sum of this is giving you 5. So at this second position, what is that number? Number is 5. Here you can see 5 is over here. Same here. For third position, A plus 3D. A plus 3D. For I think not for fourth position. For third position, A plus 2D. For fourth position, A plus 3D. For example, if you wanted to know that number which is at 25, then you will say A plus 24D. 24D. This is just a simple formula to calculate a number which is at 25 place. Clear? If you know that A is 3 and A is 2, just to simplify this, then you will get a number which would be at 25. Common difference is this much. We can find nth term, which means number of position of number, place of number. So nth term is equal to n plus n minus 1 into D. 3 plus n minus 1 into 2 is how much after. So here you can see fourth term. This fourth term 3 plus 4 4 minus 1 into 2, it is coming 9. So formula is this. This is formula. This is formula. 9 is at fourth. A plus n minus 1. What is happening over? So n minus 1 is nothing but just this. Just this. So you can easily say that this is equal to this formula. This is equal to this formula. A plus 2d. A plus n minus 1d. Like that you can. Yeah. So one thing we got very interesting. Okay. Fourth term. Fourth. So n is coming how? So n is just a position of number, yeah. Fifth position, sixth position. So 4 minus 3 will become 4 minus 1 will become 3 and d is 2. 1 2 3 4 5 like that. It is till the infinity, and we are, and if you want to now sum of n terms, n is nothing but just position of number. So sum of all these numbers, to get a sum of all these numbers, just use this formula. And here s is nothing but just a sum. S stands for sum. Remember, s is standing for sum. So sum of n terms will formula for this is n upon 2 into 2a plus n minus 1d. 2 will cut, but we will not cut this. So n upon 2, if this is a 3 upon 2, n upon 2, and this formula, complete this formula and 2 over here. Okay. We will use this formula. There is a reason behind using any formula. As you can see right now, I am saying that yes, you will use this formula. Why will you use this formula? So you use this formula to get sum of n terms, number of numbers. If you add like that, 1 plus 2 3, then 3 plus 3 9, 3 plus 3 6, then 6 plus 4 10, then 10 plus 5, it will take too much time. Rather than doing like that, you can use this simple formula, so that you can save a lot of your time. Okay. You can have infinity number. We don't care about it. Because of we have this formula. That's why. Let's take a question. For the given AP is given, arithmetic progression is given, which is 3 5 7 9 11. Okay, calculate sum up to 4 terms. Which means sum of this number, this and this. Sum of 3 5 7 9. Even you can add in your language how 5 3 8 and 9 7 16 16 8 24. It will become 24. You will also observe that after using formula s is equal to n upon 2 into 2a plus n minus 1 into d, you will see that yes, 24 is also coming by using this formula. here you can see s is equal to 4 upon 2, and then 2 multiple 3 plus 4 minus 1 into 2, then 24 is, here you can see 24 is coming by using this formula. This is your evidence. Okay, here we were adding like that, and it is coming 24 is equal to 24. This is a proof that yes, whatever formula we are using is correct. So we checked just to say confidently. Next, geometric progression. We are crystal clear about arithmetic progression. Let's explore geometric progression. Even I am also unfamiliar with this GP, but I would not say here ignore this. No, we will explore this. So geometric progression, I think it is related to coordinate geometry. No, it should not be related to coordinate geometry. Geometric progression. Okay, so remember G stands for geometric and P stands for progression. A series of the four. Okay, this is a series A plus, then AR, then AR square, then AR cube, then AR 4. Some concepts from this, some little bit concept from GP and AP. You will see that it is this concept is also coming in the chapter of, in the lecture of sets. Yeah, you will observe, because I was teaching set chapter. Then I realized right now I am realizing that yes, there are some concepts of sets in this. I can also say yes, these are concepts that are in set lecture. So this is your basic. First of all, you will have to understand AP. When you will go in set, then you will be able to understand the meaning of a set. You will be able to explore this set. Okay, let's see this GP. A, then AR, then AR a square. What is happening over? You are observing a pattern of a series. What? Exponent is increasing. Exponent is increasing. Yeah. So can we say exponent is I think whole number. 0, not 0. Yeah. Yeah, 0. If we put 0, so okay, ignore it. Exponent is increasing here. 2, then 3, then 4. By 1 it is increasing. N plus n minus 1 is called geometric progression. This series is called a geometric progression. Let's see more about this. Where common ratio, this R is nothing but just a ratio. Common ratio is equal to second term upon first term. So this upon this will come ratio. In the AP we were saying common difference, but in the discussion of GP we are observing ratio, and to get ratio just division. Second term upon first term. So third term upon second term, then n term upon n minus 2. In denominator this is decreasing. N minus 2, n minus 1 is equal to R. For example, first term, hold on. Yeah. So to get a ratio, just divide second term by one term. First term. N term nth term upon n minus 1, 1th term is equal to r. Okay, so that is how you will get a ratio. With example, let's understand. If a first term is how much? A is equal to 4, then common ratio will be r is equal to 1 upon 2. No. Then GP is this 4, 2, 1. If first is this 4, this is 4, and ratio is this, ratio is given 1 upon 2. So what is happening over here? We are saying 1 upon 2, okay? V upon 1 upon 2, and first term is how much? First term it is talking about. So let's say this is x, and here this first is this much 4. So you can easily say that it will go over here, and x is coming as a 2. So x is nothing but just a second term. So second term is a 2. Okay, so this is a 2 second term, we know. And then same second term. Then like that we can calculate the third term, then fourth term. Like that we can calculate. If first term is given and ratio is given, then here you can see GP is coming how much? 4, 2, 1, 1 upon 2, 1 upon 4, 1 upon 5. You will see that ratio is 1 upon 2, and you know that A is 4 and ratio is already 1 upon 2. How? Just 4, not 4, 2 upon 4, 2 upon 4. Then you are then what is happening? 1 upon 2, 1 upon 2. We can find n term of we can find nth term. Remember, nth is nothing but just position of number, position of a term. So we can find nth term of an GP as by this formula. Nth term a into r raised to power n minus 1. So here a is nothing but just 4, and r is 1 upon 2, then n minus 1. After simplifying this, fifth term is equal to 4 upon, for example, we want to know fifth term. So 4 multiple 1 upon 2, then 5 minus 1. Okay. Then here after simplifying this, 1 upon 4 is coming as a output, and meaning of this output is just at fifth position, at fifth place, number is how much? Term is 1 upon 4. This is what is the meaning of 1 upon 4. Okay, so at the fifth place, number is 1 upon 4. Sum of n terms of a GP. How to calculate sum of n terms of a GP? So for this we have this formula. S is equal to A, then 1 minus R, then n upon 1 minus R. You can see what's the difference between this and this. A as it, then R, n minus 1. Okay, 1 minus R, then upon 1 minus R, and R raised to power n. This is formula to calculate sum of n terms of a GP. For GP series having infinity number of terms, how to calculate in a series which is having infinity number of terms? In that case, if R is less than 1, then A, to calculate this S infinity is equal to A upon 1 minus R. A upon 1 minus R. We know that what is A? A is just a number which is at first place, and R is nothing but just ratio ratio of two terms. Okay, if r is greater than 1, okay, r is greater than 1, it means this is a natural number, but not natural number. It is not taking 1. This is not taking 1. It is, if ratio is uh, if ratio is increasing. What is increasing? Yeah. If r is greater than 1, then we have this formula here. S infinity is equal to infinity. Let's understand this with examples. 4, 2, 1, 1 upon 2, 1 upon 4, 1 upon 8, till the infinity. Find some. Okay. No problem. Here we can see this is coming 1 upon 2, which is 0.5. This will come 0.5. Of course, this is less than 1. In that case, we will use this formula, a upon 1 minus r. Okay, a upon, so a is how much? 4, and r is 1 upon 2. There is a fraction in denominator, so yes, this formula. What formula? This one. After simplifying, s is coming how much? 8 only 8. Yes, it is coming 8 because of this is decreasing. We can see this series is decreasing. 8 is coming. Yeah, till here this is complete. We have completed a quadratic equation, AP, GP, arithmetic progression, geometric progression, and I am happy that I completed this. S is equal to 8. We will take some question based on GP and based on AP, arithmetic progression, geometric progression. Next we have coordinate geometry. We are more familiar with this coordinate geometry. And it doesn't mean that we will ignore it. No, we will have to understand this quadratic equation.